two airplanes are flying in the air at the same height. Airplane A is flying east at 250 miles per hour and airplane B is flying north at 300 miles per hour. If they are both heading to the same airport located 30 miles east of airplane A and 40 miles north of airplane B, at what rate is the distance between airplanes changing? Okay, so let's draw the situation here, and this is the airport here. Okay, let's label that as our airport here. And then let's label this distance from the airport to airplane A here as X. And then let's also label the distance from airplane B here to the airport as Y. Right? And then the speed of this plane here, which the change of this x with respect to time, right? So we will have dx dt here. And what is dx dt? It is 250 miles per hour. So we will have 250 miles per hour. Good. However, the sign will be negative. Why? Because the distance between the airport and the plane here will be decreasing, right? So I will have this one as minus 250. Good. And then airplane B is flying north at 300 miles per hour. So that is the speed of this airplane B approaching the airport, which is dy dt. And that dy dt here is what? Minus 300 miles per hour. Why minus? Because the distance here, y, will be decreasing, right? Because this plane B is approaching the airport. Okay, now let's see here. The plane A, airport, and plane B form a right angle triangle, right? Because this is the east direction and this is the north direction. And that means that they are 90 degrees of each other. So we will have this as 90 degrees here. And then let's name the distance between plane A and plane B as Z. Good. And we are looking for the change of this distance here, which is dz dt. And that is the equation, right? Okay. And how to do that? Okay, we have right angle triangle, so obviously we will need to use Pythagorean theorem. Let's do that. Pythagorean theorem, which is, of course, the distance here, x squared, and then plus y squared here is equal to z squared. Good. And all of that is a function of time. So all that we need to do is to take implicit differentiation with respect to t. So I will have implicit differentiation with respect to time. Good. And on the left hand side I will have 2x, but that is differentiation with respect to x. We need to with respect to time. So we will have dx dt. And then we will have plus 2y here. So in this case we need to multiply it by dy dt. And here we also have z squared, so I will have 2z dz dt. Okay, and I think we can divide both sides here by 2z, right? So we'll have this divided by 2z, this also divided by 2z, and this one will be divided by 2z. Okay, and this will cancel each other, and this 2 and 2 also cancel, and this 2 and 2 is cancelled. So we will have our dz dt here. Dz dt is equal to x over z and then dx dt, and then plus we also have y over z, but this time multiplied by dy dt. And that is the most important equation in this problem. dz dt is equal to x over z multiplied by dx dt, then plus y over z multiplied by dy dt. And then what is the question? If they are both heading to the same airport located 30 miles east of airplane A and 40 miles of airplane B. So that is give us the x and y, right? So we will have when x is the distance from the airplane A to the airport, so that is 30 miles. And then what is y? Y is the distance between plane B and the airport, so I will have y is equal to 40 here. And here we have our x, our y. We also have dx dt and dy dt. What we don't have is the z, but we can get z from here, right? So we will have z squared here. Z squared is equal to x squared plus y squared. But that means that we will have 30 squared plus 40 squared. Okay, and that means that z squared is equal to 900 plus 1600, and that will be 2500. And so we will have z is equal to 50, and the unit is miles, of course. Okay, and then all that we need to do is to plug in the numerical values. So we'll have to plug in the numbers. So we will need to plug in the numbers, which is dz dt when x is equal to 30 and y is equal to 40. And that will be, so we will have our x here is 30. Okay, so we have 30 divided by z, which is 50, then multiplied by dx dt, we will have minus 250, and then plus y, y is 40, z is 50, and then we will have minus 300. So here we will have this one here, this term is 0.6 multiplied by minus 250, so we'll have minus 150, and then we will have here, we will have plus minus 240, and that will equal to minus 390. So at what rate is the distance between the airplanes changing? That will be minus 390, and the unit here is miles per hour, right? And the minus sign is because the distance here is decreasing, right? Because it is approaching to the same airport, and the unit is miles per hour, of course, because dz is in miles and the time is in hour. So here is the final answer for this question, minus 390 miles per hour. Hopefully I did not make any mistakes during my calculation. Thank you for watching and see you in the next video. Bye bye.